This preamble is shared between the 3 videos for the 3 courses and contains first a description of what was required by the exercise, then my proposed solution, and the description as per the requirements within the exercise, and finally some considerations specific for the proposed solution. The exercise was to build up a model using one of the 3 options provided by the course organizers in terms of technology, but stating a problem that they define along with the data, using the dataset that they provided. The dataset was quite small, was less than 10,000 observations. I provided also a description of the process to identify the best model, and then the validation to compare the models, and finally the test of the model selected as the best. In my case, I selected Excel for 2 reasons. First, because the request was to use a small data set, less than 10,000 lines, and to deliver a prediction. Therefore, was a natural candidate for linear regression. And second, because in corporate environments, usually Excel is already available. And the request was to have a couple of models to compare. And so I decided to use the linear regression with a different mix of features. This is the summary of the models, as you can see. So, and simply all the models anyway have to deliver a prediction on the target, the net hourly electrical energy output. What will be the measure to assess the value of each model, and that was the mean square error. As a target to assess if the model was useful or not, identify the 5% of the average target value, so 22.72. And then I had to split the data set. In Excel you cannot do that automatically, so I did that manually, and I split into 3 parts: 70% for the training, 20% for the validation, so to compare the 3 models, and 10% to verify on data that are not been seen before, and the best of the 3. This is the process that I followed. First, on the trained data set, I obtained the coefficients that have to be applied to the model equation. The model equation is simply the features times the coefficient plus the intercept. We verify the performance as mean square error. After doing that on the trained data set, I did also the same on the validation data set. So using the same equation, compare the mean square error across the 3 models. The model A is this model. As you can see, this is the output of the regression tool in Excel, and it provides plenty of information, including the predicted value for each one of the observation. And then I compare this predicted value versus the value to identify the mean square error. Also, it provides us some charts that I'm not going to explain, but this is the summary of 3 models. As you can see, the mean square error across the 3 models, the last 2 have more or less the same value, marginal difference, but the best one was this one, and it was significantly different, and it was slightly worse than the target MSE of 22.72, but anyway, I tried to apply it on the test data set, and this is the result. As you can see, seeing the same model, model A, across the 3 phases, train, validation, test, the validation was worsening, but the test was more or less in line with the train and better than the one was expected. And why I obtained these results? Probably because the partitioning wasn't done by reshuffling the data, but was done by partitioning physically the data. If I were to use a different tool, it will generate a subset of 70, 20, 10%, but shuffling the data, and therefore probably will get some different results. The model is more complex than others, but in this case the target audience was anyway operational people. In cases when the model is for communication purposes, it's better to have a less precise model, but easier to explain to the audience.